Today in chemistry of class 11 chapter 2 atomic structure we are going to learn the present model of the atom. That is, till now you have learned that Thomson model, the Ford model, then Bohr's model. Now the Bohr's model in detail, and now we will learn the exact model of the atom which we are learning today, which we study in our chemistry. So before proceeding to that topic, we will now talk about some topic like dual nature of light and quantum mechanical model of atom. So when the Planck quantum theory was given, and Planck quantum theory was not able to explain certain things that I already explained you earlier. So somewhat similar situation arose in case of classical mechanics, which was based on Newton's laws of motion. Classical mechanics, it could successfully explain the motion of not only ordinary bodies like bullet and cricket, but also of astronomical bodies like motion of planets around the sun. Means Newton was able to explain the motion of all the bodies present on the earth as well as the astronomical bodies, but it failed to explain the motion of electrons around the nucleus. So Newton mechanics was not able to explain the movement of electron around the nucleus. So to deal with this problem, a new mechanics came into existence, that is known as the quantum mechanics, right? So now we will learn the atom of structure according to the quantum mechanics. In quantum mechanics, we are learning the dual nature of matter. Till now, we studied that electromagnetic radiations consist of dual nature, means they are behaving like a particle as well as wave. Now we will learn the dual nature of matter. In 1923, Louis D. Broglie, he was a scientist, proposed that not only electromagnetic radiation, see this, electromagnetic radiation display particle-like nature along with wave-like nature, means particle and wave dual nature. But all matters should also display wave-like properties, means according to D. Broglie, all the matter in the world should display wave-like property, means Newton's mechanics also, and wave-like property, means it should behave like a both wave and particle-like motion. So D. Broglie worked on this, and he gave relation between the wavelength of a particle of a given mass when moving with a certain velocity. So what was the relation and how he gave this relation? See, this was the given by Einstein equation, E is equal to mc square. In this equation, the particle is considered as a particle. The matter is considered as a particle of mass m, and which is moving with the speed of light, square of the speed of light, E is equal to mc square. So in this, particle nature is proposed, matter ka particle nature, matter. And in this, wave nature, E is equal to h nu. Nu is the property of a wave. So this is wave nature of the particle, So on equating both these, Einstein equation and Planck's equation, h nu is equal to mc square. Now nu is equal to, nu is the frequency, m is the mass, h is the Planck's constant, and c is the speed of light. So nu is equal to mc square by h. You can see mc square by h is substituted here. Now mu lambda is equal to c. You know this relation, c is equal to mu lambda. So lambda is equal to c upon nu. We are putting the value of nu here in the equation, we are putting the value of nu. So ch upon mc square. Now c will be cancelled, so h upon mc. So the relation will be lambda is equal to h upon mc. That is for photon, because the photon moves with the speed of light. This is for photon having mass m and h upon mc, right? Now lambda is equal to h upon mv for particle of mass m. For any particle of mass m, this is for photon, this is for any particle of mass m, and this particle will move with velocity v, particle moving with the velocity v. So lambda is equal to h upon nv is the relation given for a particle which is having mass m and velocity v, and the wavelength of the particle will be equal to lambda is equal to h upon mv. This was a very important relation given by D. Broglie, or we can say lambda is equal to h upon p. P is the momentum, right? So remember this, lambda is equal to h upon mv. This is the wavelength of the particle of mass m moving with a velocity v. H is the Planck's constant. This is for photon. Remember this, student, that the rest mass of photon is 0. Rest mass of photon is 0. Means photon has its existence till the time it is moving. As soon as the photon stops moving, it has no mass. So there is no existence of photon. So photon, a moving photon, has mass m. Photon is the only particle which has momentum but not mass, right? It has momentum but no mass, because when it is moving with the velocity with c or v. It is moving with the velocity c, and as soon as it will stop, its mass will be 0. So a photon is the only particle which has momentum but no mass. So that is a different thing. We'll come back to our topic. Lambda is equal to h upon mv. This is de Broglie wave equation. De Broglie wave equation. This equation relates this relates wavelength of a particle of mass m, right? So it relates both particle nature and wave nature of a matter. Now, de Broglie relationship and waves theory, Bohr theory. Bohr said that the Bohr's angular momentum of an electron in a stationary orbit is an integral multiple of h upon 2 pi, that we studied earlier, right? So how de Broglie relationship and Bohr theory are true. So for a circular orbit of radius r, before this we must learn what is constructive interference and what is destructive interference, right? Suppose you are in a room and your teacher is giving out lecture. So the voice is very clear, you are able to understand each and every word. But what will happen if suppose the class is having a strength of 40 students, all students start speaking together? Will you able to listen the voice of any one of them? No. So that is considered as a noise. That is considered as a noise because at that time waves from all directions are coming. Waves from all directions are coming and are interfering with each other. So none of the voice is clear. As you can see, there are three waves. There are three sound waves, 1, 2 and 3. Both are interfering with each other and cutting out each other. So that is considered as a noise. This is known as destructive interference. Destructive interference, right? This is known as destructive interference. And what is second is constructive interference. Suppose 20 persons are standing together in front of a mic and are singing the same song. That is known as chorus. Each voice is clear, very clear, because each one is having the similar waves coming from their mouth at each means at a particular time. So this is known as constructive interference. This is known as constructive interference. Hope you might have understood this. So this is destructive and constructive interference. So if two waves are, suppose this is the orbit of the electron and this is the second wave, which is not in position with the first wave. This is the first wave and this is the second wave. So this will result in destructive interference. And in this case, this will be a non-standing wave. And it will radiate energy. And will be unstable. See, suppose this is the orbit of energy level 1 and this is the orbit of energy level 2. Both are creating both have different energy, 1 and 2. So both will produce destructive interference and the wave will be non-standing or it will radiate energy and will be unstable. But suppose two waves are on each other. And are moving. So this will result in the constructive interference. So this will be a standing wave. It will not radiate energy and will be stable. So hope you might have understood destructive and constructive interference. In this, the value of n will be 1 of both of them. In this, the value of n is 1, 2, means different. So this result in destructive interference and this will result in constructive interference. Same thing was given by in this relation, de Broglie relationship and Bohr's theory. See, for a particular orbit of radius r, before this, see this thing. If this is a wave, so this is known as lambda. The path covered by the wave in a particular time is known as wavelength. It is known as wavelength. So suppose in a circular orbit, this is a particle and it covers a path of radius r. So its path will be 2 pi r and this will be equal to lambda. This will be equal to lambda, right? So for a particular orbit of radius r, the circumference of the orbit is 2 pi r and 2 pi r is equal to n lambda, and it is the integral multiple, that is n lambda, energy level n. So 2 pi r is equal to n lambda. Now according to de Broglie, lambda is equal to h upon mv. Lambda will be equal to 2 pi r nh upon mv, or mvr is equal to nh upon 2 pi. And this was the Bohr's postulate. What was Bohr's postulate? Bohr's postulate that angular momentum of an electron is in a stationary orbit is an integral multiple of h upon 2 pi. So both the things are clear. What Bohr gave earlier and what de Broglie gave after the dual nature of light was established. Both are proved, means both are right. Bohr gave this theory earlier and de Broglie, when the relation between the particle as this particle and wave was established, he gave this relation and both relations are true, right? What is true? That the angular momentum of an electron is an integral multiple of h upon 2 pi. So this is true, right? Now once it was established, many theories came into existence and many scientists started working on the describing the structure of the atom, how electron exists, how orbits are given, right? So one of the important principle was given by Werner Heisenberg, and this is known as Heisenberg uncertainty principle. Heisenberg uncertainty principle. Uncertainty means that is not certain, जो निश्चित नहीं है. So Heisenberg uncertainty principle. What is this? He predicted the motion and this principle is associated with the motion and position of the electron around nucleus. Means where the electrons are located around the nucleus, where the electrons are located, how they are located, now how is the what is the motion of the electron, what is the velocity, all these things were considered by Heisenberg, and he gave the motion and position of the electron around the nucleus. So what was that? Werner Heisenberg came to the conclusion that it is not possible to determine exactly both the position of a particle and the momentum at the same moment of time. So what is this? This is something you can understand by seeing your ceiling fan, that in your ceiling fan there are 3 blades, and when they are moving seems like a wave. So if I ask you, suppose you put by paint, you put 1 2 3 on the blade, you put 1 2 and 3, and I ask at a certain time t, what is the position of blade 1 and what is its velocity. So if you want to know the velocity of blade number 1, you have to stop that blade. Because it is moving very fast and it is impossible to predict the velocity of the blade at that particular instant of time. So if you are considering the position of the blade, you are not able to explain the velocity. There is uncertainty in the velocity, or the velocity will not be very precise. And if you are considering the velocity of the blade, I ask you to predict the velocity of the blade, you will predict the velocity of the blade, but at that time the position will not be very precise. The position of the blade will not be very precise. Means either you can predict the position or you can predict the velocity. And this was given by Heisenberg uncertainty principle, right? And he gave this relation, that is delta x. Delta x is the uncertainty in position. Delta p is the uncertainty in momentum. And delta x into delta p is greater than or equal to h upon 4 pi. This is the relation given by Heisenberg, and it is very important relation. And in the further classes, we will learn how this relation was helpful in predicting the structure of the atom, the position of the electron, the velocity of the electron, how electrons are filled in a particular orbital, right? So we will learn this in coming lecture. Till then, you keep on studying all these things that I told you today, that dual nature of the matter, this lambda is equal to h on v, de Broglie wave equation, Heisenberg uncertainty principle. Further we will continue in next lecture. Till then, goodbye.